Hello everybody, Santiago here. I made this video so we could dive into Unit 8 a little bit more. So we're going to explore what I mean by tension in games by looking at the tension between individual level and group level incentives in the prisoner's dilemma. So some brief highlights of the unit so far. We talked about an important assumption in game theory being that individuals act in order to maximize their own utility. And utility, remember, is this numerical measure of the outcome of a game, which could be profit, happiness, reproductive success. We saw all of this earlier in the unit. So we're taking this to mean that the individuals are selfish. They're, right, if they act in order to maximize their own utility, they're only looking at their personal gain, then we're calling them selfish agents. And a big question in the unit is, can selfish individuals cooperate? So let's go back to the prisoner's dilemma. The numbers in this prisoner's dilemma are a little bit different than those Melanie used, but the game is still essentially the same. If you want to compare this one with the other one and go through that process of deliberation that each of the players goes through to make their decision, I encourage you to do that. Now, to make everything even clearer, in the attempt to make things clear, I color coded the agents and the utilities that they receive. So player one is in blue, and he can choose between the blue, cooperate, and defect. Player two is in green, and they can choose between the green, cooperate, and defect. And depending on what they choose, if player one chooses cooperate, player two chooses defect, then they're in this cell. This is the outcome. And player one gets the utility on the left, player two gets the utility on the right. So to look at this tension, let's decompose, let's rewrite the game as the sum of cooperative and selfish forces. And to do this, I'm going to use a technique that was developed in this paper I'm citing below, Strategic and Behavioral Decomposition of Games. And I'm adding this paper to the supplementary materials page of the website, and I encourage you to take a look at it. Unfortunately, I can't go through all the details of the paper, everything they do. There's a lot of good stuff, but I gotta keep it simple, keep it short, and point you where to find more. So, all right, let's keep going. So if I apply the decomposition to this prisoner's dilemma game, I get these three components. So if you want to make sure, pause the video, add these three matrices down here, add them up and see that you get this one. And yeah, so all right, so let's see what's going on. What are these components telling us? What do you think they're telling us? What kind of information is contained in each of these components, and why is it that we can separate these information? So feel free to pause the video, analyze each of these components, see what you think is going on, and because I'm about to talk about it. So continuing, this first component, we interpret it to be this kind of fluff. It contains no real information. It's not really doing anything because it contributes the same value to all the utilities of each of the players. So it doesn't have to be the same value for both players, right? We see here that both players all have two. It could be different, but I'm keeping it simple. And so this component of the game contains no info because since it's the same value for all of the outcomes, well, in game theory, we're interested in comparing the results of different outcomes. So any way we compare the outcomes is going to cancel out this common value. So saying it's just fluff, there's no real information here. The authors of the paper call this the kernel. Now, the second component we say contains the game's selfish information. Now, why is that? Well, so check out the other components. Can you gain anything from changing your own strategy alone? No, right? So check out the kernel. If you, let's say player two is fixed playing cooperate or defect, if you switch between cooperate or defect, is there any incentive for you to change your strategy? No. So all of that information, all of that individual level incentive is contained in this middle component, in this selfish info component, which the authors called the Nash or strategic component. And the reason they call it the Nash component is that this component contains all the necessary information in a game to compute Nash equilibria, which we haven't really talked about, so I won't really get into more. But right in this entire game, we can decompose it into these three layers, these three components. But to compute Nash equilibrium, we only need this. It's pretty fascinating. So if you're curious, if you're liking this, check out the paper, study more game theory. But anyway, the next component, this last component, doesn't have any selfish information, but something's going on. It's not trivial like the kernel. It's not just the same value, right? So what do you think is going on here? I'm calling it leftover info to keep it mysterious. We haven't figured out what this component does. So maybe pause the video, think about it a little bit. Here, let me blow it up. There's the leftover info component. What is happening with it? Okay, pause the video. Okay, so look, in this component, each agent is powerless to change their own utility alone. But what happens when the other agent changes their strategy? So let's say, okay, start over. Let's say you're player one and player two is playing cooperate. You have a choice between cooperate and getting a two or defect and getting a two. So if that's all you're looking at, you don't care, right? You're not, this isn't going to sway your decision either way. But what happens when you play cooperate and what happens when you play defect? When you play cooperate, agent 2 is receiving a payoff of positive 2, no matter what they do. If you play defect, agent 2 is getting a payoff of negative 2, no matter what they do. So it's like your decision is affecting the other person. So this idea, they call it externalities in economics. So an externality is a utility imposed on another agent, on another person, another group of people. Is utility imposed on others from your actions. So a simple example, if I play music really loud and it bothers my neighbor, then they're receiving a negative externality from something I'm doing, right? So maybe I'm making a decision that gives me a nice private payoff, a utility, but it gives my neighbor a negative utility. That's the idea of externalities. So this leftover information component, I'm calling, the authors called the behavioral component, I'm calling the externalities component. Sorry for all the names. I hope this is not confusing. Yeah, so I talked about this externalities. You do something, the result creates utility. The result is utility for yourself and for others. So externality is this utility that gets imposed on others. Now, just this, so let's look at the prisoner's dilemma again, ignoring the kernel. So when I cooperate, I'm not getting the best for myself no matter what you do, right? Look at that negative one. If you cooperate and I cooperate, I'm getting a negative one. If you defect and I cooperate, I get a negative one. Remember, we're only looking at the selfish info component. So looking at the selfish info, I'd rather always defect. I always get a better individual payoff by defecting. Following, if I'm selfish, then I'm always going to defect. And that is shown right here. Because being selfish, I don't care about a 2 or a 2 or a -2 and a -2, right? I only care about this individual. I want to maximize individually. So following our individual interest, we choose to defect. But that hurts each other because when we defect, we impose a payoff of -2 on one another, right? So here player 1 is defecting, player 2 gets a -2. Here player 2 is defecting, player 1 gets a -2. So following our individual interest, we hurt each other. If we both cooperated, we'd supply each other with this +2 utility going against that -1 selfish utility. But it'd be better, right? If we look at the full game, we'd be better off both cooperating than both defecting. So the prisoner's dilemma exemplifies this tension between cooperating and defecting, between what does our selfish, what does the individual level pull us towards, what does it want us to do, and what does the group level want us to do, right? So it's better if we cooperate, but individualism sort of unravels it, and we end up defecting. Now, let me just go back. So we talked about in the previous units, we talked about tit for tat. And so how does tit for tat make cooperation work? So tit for tat actually changes the game. One way it changes the game is the game becomes repeated. And another way is that the strategies change. So if you play tit for tat, you're not simply playing cooperate or defect, right? You're playing this, it's almost like this higher level strategy in this repeated game. And so what this ultimately ends up doing is it brings the externalities into the selfish information and it makes cooperating attractive to someone selfish. That's the only way, right? We're assuming the individuals are selfish. So at the end of the day, no matter how many hoops we jump through, the agents are going to behave selfishly. So the only way for them to cooperate, at least with these assumptions, is to make cooperation something a selfish agent would play. So I could barely get into that. The stuff I think is super cool, and I suggest you check out that cited paper. They talk about tit for tat, and they show with more detail how things change, how things move around, how some of the externalities end up affecting a selfish level choice, which is how tit for tat in the repeated game makes cooperation possible. So let me lastly tell you the quote unquote rules to create the components of these 2x2 games so you can play around. And in fact, I'm gonna make an additional homework which is gonna be optional for you to explore all of this a little bit more. So in it, I'll ask you to follow these rules and create different kinds of 2x2 games where cooperation is aligned with selfish incentives or it's not, like we just saw, and so on. All kinds of interesting examples for you to play around with and explore. So let me tell you these rules. And these quote unquote rules are actually mathematical symmetries that make this whole thing work, but I'm not going to get into the details of it. But so with the selfish component, every pair of alternative individual choices must be negatives of each other. Sorry, I forgot some words here. It must be negatives of each other. Anyway, so here we see I put an example. Player 1 chooses strategy A, and player 2 chooses strategy A. So player 1 gets a payoff of A. If they switched, they'd get a payoff of -A. And so we can see this idea repeats throughout this selfish info component. The externality component, on the other hand, remember that there's no individual power. So here, if player 2 is choosing A, you're player 1, you're just getting an M no matter what. The only way you can get something different is if the other agent changes their strategy. So here, when the other agent changes their strategy, you get the negative of what you were getting, right? So player 2, by choosing A, imposes M, a utility of M. And then if they played B, they impose negative M. And so just to be clear, M could be 3, so this would be 3, 3, negative 3, negative 3, but M could be negative 3. So then over here we'd have negative 3, negative 3, and then over here we'd have negative, negative 3, which would be, so we'd have positive 3, positive 3. And then finally, the kernel was the same value for all the utilities of each agent. So agent 1 would have the common value j, whatever j is, and agent 2 would have whatever value k is throughout. And so here it is. Here are the rules. And thanks for watching, everybody. I hope this made sense. If anything, send me an email, post questions on the forums. I'll be happy to explain any of this a little more. And yeah, thanks for watching. Have a great day. Bye.